All right, this is video C14, and we are looking at permutations with repeats, elements not all different. I try to remember to say that because to me, there's the repetition where you can use an element over and over again from the fundamental beginning principle. And then if I use repeats here, I got to be careful so that you know what's going on. Anyway, here's our formula. But if you watched the previous video, you already know how to use that. N, in this case, is the total of number of elements you're arranging, and count every single one. Don't care about repetition. And R, S, and T are the ones that do the repeating or are not all different. Oh, we already did that question. Maybe you haven't seen that video. So here we go. There are 1, 2, 3, 4 letters. 4 factorial, whoopsies. 4 factorial. And then we got 1, 2, 3 O's. So 3 factorial. I'm going to put in a 1. There we go. I tend to do that. And that's going to be 4. Now, there's a lot of really great First Nation names for doing this math. I like Gisakus. When I first started out, I was teaching in York and I had wonderful students. I know some really nice people from Gisakus. But it also is just beautiful in math. So here we go. We're going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, count again. I don't want to screw up. Okay, so all the letters. Now we have to look for the repeats. So I got a K, another K. So I'm going to go 2 factorial. I'm going to put a K there. Then I need to find the next, I go to the next letter. So there's 1, 2, 3, 4, 5 E's. I count them all at once. So that gives me 1, 2, 3, 4, 5. Now the next letter I hit is an S. There's an S there, and there's another S. So it's going to be 2 factorial. I hope you can see where crossing them off is going to make your life easy, and also labeling them here. And we got the 2 O's. All right. Now, I used to make this really complicated until my students pointed out, don't overthink this. All you do is 11 factorial divided by 2 factorial, divided by 5 factorial, divided by 2 factorial, divided by 2 factorial. There we go. I used to make people work this all out and then come up with an answer, and now it's much easier. So I'm just going to write that 11 factorial divided by 2 factorial, divided by 5 factorial, divided by 2 factorial, divided by 2 factorial. That's your key punch. And that's it. And ta-da! There are exactly 41,580 different ways of rearranging the letters in the word Kisakus. Now, just for fun, if all the letters in Kisakus were different, then you would have 11 factorial, and you'd have like 39 million ways of arranging it. So it's significantly less because there is replicated letters. That being said, now you know how to do it. Pause the video and complete Wiki. I'm sorry, Pepikis, Mississippi, Saskatchewan. And just so you know, you can also use it on numbers. It doesn't have to be just letters. It's just the way it's always been introduced. Okay, pause the video, do the math, and then turn it back on and check your answers. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh. I guess I should have chose something else that wasn't 11 letters, but. All right, so 11 in total. And now I go, there are 2 P's. And then there's 1, 2, 3, 4 E's. I'm going to ignore the K. Some people will put like a 1 factorial on the bottom, so, and then like they're counting every single letter, but don't need to. Okay, so I'm just going to cross it off. And now you've got 2 I's and 2 S's. Zero, 7, 9. All right, 207,900. All right, Mississippi. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, sorry. Apparently I should have checked these out before. Because look, it's 11 again. All right, there's only one out, so I'm just going to cross it off. Now we've got 1, 2, 3, 4 I's. And so 1, 2, 3, 4. And then we've got 1, 2, 3, 4 S's. And then we have 2 factorial for the P's. Factorial, divide by 4. Factorial, divide by 4. Factorial. Oh, now I messed it up. Divide by 2. Factorial. 3, 4, 6, 5, 0. And there we go. 34,650 different ways that you can rearrange the letters of Mississippi. Last year. I hope there's not 11 letters in the word Saskatchewan. 1, 2, 3, 4, 5, 8, 9, 10, 11. Yay! All right, now we have 2 factorial for the S. Now we've got 1, 2, 3. 2 factorial, oops, S, that's the A. There's only 1 K. There's only 1 T. No more duplicates. Enough number. 9, 916. So that makes sense. It's a big number because we had more letters to start with, and there weren't as many repeats. So, and the last one, which is something I thought we should just try. Like I said, it can be anything that does repeating. Hold on. Yeah, a little easier to see. Me numbers too. So 1, 2, 3, 4, 5, 6, 7, 8. Now I've got 3 2s. I'm going to circle it just so I don't get it, start trying to calculate that with that later. And then there's an 8. And then I've got 2 factorial for my 9s. And 2 factorial for my 6s. 8 factorial divided by 2. Whoopsies. I can do that. In case you're worried I screwed that up, I can do it in order. Just look at the same answer. Ta-da! Isn't that nice? It is like one of my favorite ones because the moment you see elements that are identical, boom, it's got to be done this way.